In the summer, to my hot.
Welcome back to Chemistry with Kylie,
Emma, Michelle.
After watching today's video, you'll be able to know everything about electronic configuration and orbital diagrams.
Okay, let's get started. Okay guys, so to start we're going to talk about the 4 quantum numbers. Quantum numbers define shape, energy, position, and spin of an electron.
The principal quantum number tells you about the energy level the electron is in.
The angular quantum number tells you about the shape as in S, P, D, and F. These are the correct shapes. The magnetic quantum number tells you the orientation of the electron in a given space.
The spin quantum number tells you about the spin of the electron, which can be clockwise or counterclockwise.
Let's review some information about orbitals. The number of orbitals in the shape blocks, S, P, D, and F, and then the energy levels can be calculated by N squared. The maximum number of electrons can be calculated by 2N squared. Another important thing to remember is that the D block is 1 energy level lower, and the F block is 2.
So let's go through the order of filling orbitals when writing an electronic configuration. You have to fill the orbitals in the following order: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, and 6d10. So, when we say the numbers 1 through 7, this is the energy levels that can be viewed on the side of your periodic table of elements. Numbers 1, 2, 3, 4, 5, 6, and 7. So this section is the S block, this section is the D block, this section is the P block, and this section is the F block.
Great! Now we're going to show you how to write the electronic configuration of the noble gas, argon. Okay, so first we're going to start off with writing 1s2 for this first period. Then we're going to do 2s2, 2p6, 3s2, and then 3p6. Go.
For elements that aren't noble gases, you can use the noble gas notation as a shortcut for writing the electronic configuration of elements. So now I'm going to show you how to do the shortcut for writing the electron configuration of lead. P, B. Let's find it. Here we are. Okay, so now we have to find the previous noble gas, which would be xenon over here. So, in brackets, we put the symbol for xenon. Then we do 6, because we're in the 6th energy level. We do 6s2. Then we have to do the F block, which is symbolized here by the star. So we do 4f14. Then we do 5d10. And then we finish with the 6th energy level in the P block, the second element over, 6p2.
Great job, guys, but there are some exceptions to this common electronic configuration rules.
So, for starters, the first 3 exceptions are chromium, molybdenum, and tungsten, and they prefer to have half-filled orbitals, whereas copper, silver, and gold prefer to have completely filled orbitals. So now we're going to show you how to write the electronic configuration for these elements that are exceptions to the common rules. But Michelle, what does it mean to be half-filled and full-filled?
To be half-filled means that all the electrons are unpaired, while to be filled means that they all are paired. Elements want to be like this so that they're more stable.
Oh, I I get it.
Okay, so we're gonna try writing out one of these half-filled orbitals. So over here we have chromium, the fourth element in the D block. Now normally when you would think of chromium, you would write it as here, Ar, argon, and then 4s2, and then 3d4. But see, this is wrong because for a half-filled orbital, D would want to have 5 electrons. So what you do is you take 1 electron from the valence orbital, from S, and so this would be wrong, and you make it argon, 4s1, 3d5. Now let's talk about orbital diagrams.
So before we start, there are 3 different principles or rules that we need to go over. So the first one is the off-belt principle, and that's saying that the electrons will occupy the lowest energy level orbital that will receive it. So first the electrons will occupy the first energy level in the S block before, the 6th energy level in the P block. The Pauli exclusion principle is where no 2 electrons within an atom may have an identical set of all 4 quantum numbers. So you can't have all electrons with the same spin or with the same shape. And the last rule is the Hund's rule, where electrons will occupy all empty orbitals with single electrons having parallel spins. So you have to do all of the electrons with the parallel spins before entering the orbitals.
Okay, so now we're going to focus on orbital diagrams. So you want to write out the electronic configuration first, just to make it easier for yourself so that you understand how many electrons are in each orbital in each energy shell. So first what you want to do is orbital diagrams basically show the spin of different electrons and which shells are filled and which aren't. So you'd write this out by saying 2s, then 2p.
Michelle, why is there 1 line for S and 3 lines for P?
Because there's 1 orbital in the S block and 3 in the P block.
Oh, I
And
get
each
it
orbital
now.
holds 2 electrons.
Thanks.
So this is how you'd start your orbital diagram. So since there are 2 electrons in the shell, you would indicate them with opposite spins. Because of Hund's rule, you know that you can't fill each orbital until you've filled each orbital with at least 1 electron. So, since there are 2 electrons here, you would indicate them having parallel spins.
Then these 2 electrons remain unpaired because normally there would be a third forward-facing arrow, then 3 downward-facing arrows, but there are no more electrons to fill that shell, so we're left with 2 unpaired electrons.
Thank you for watching KEMistry!